I promise you this video about vector mathematics will interest you. That's because every large language model on the planet, ChatGPT, Claude, Gemini, all of them, they don't read words the way that you and I do. They can't because they're machines. They only understand numbers. So how does a machine that only speaks number somehow write poetry, answer legal questions, and hold conversations that genuinely feel human? The answer is one of the most elegant ideas in the history of computer science, and I can explain it to you with a simple equation. That's logical, and it's also using real vector mathematics. It actually works. And once you understand why it works, you'll understand something about AI that 90% of people, including most people building AI products, completely miss. So if you stay with me for 5 minutes, I'm going to change the way that you think about artificial intelligence. Let's start with the fundamental problem. You and I look at the word dog, and we instantly access a lifetime of associations. We know what a dog looks like, we know what they sound like, we know how they behave, we know they're related to wolves, but they're different from cat, but they're much similar to a cat than a lawnmower. A computer looks at the word and sees D-O-G, 3 characters, and that's it. There's no meaning there, just these abstract symbols. So in the early days of AI, researchers found a problem. They could get a computer to store words, search for words, even count words, but they couldn't get it to understand that the word happy and joyous are basically the same thing, while happy and funeral are worlds apart. So that question confounded AI researchers for decades, because how do you represent meaning that some humans feel intuitively as a set of numbers that a machine can actually compute with? The answer it came up with was breathtakingly simple. You turn every word into a location on a map. Not a two-dimensional map like we see on your phone, but a multi-dimensional map that operates with millions or billions of different dimensions. So now imagine a vast, sprawling map, not of places, but of meanings. And every single word in the English language has a specific position on that map. Now, if you're standing in the middle of the map and you need to work out how to get to that location of that word, the pathway you take is called a vector. So think of vector like a set of coordinates, a bit like a GPS coordinates that tell you exactly where Sydney is on the surface of the Earth. A word vector tells you where the word sits in the space of meaning. Words that are similar, strangely enough, are grouped together, and words that are unrelated sit far apart. So on this map, dog and puppy are practically on top of each other. Dog and wolf are nearby, but they're not quite as close, whereas dog and lawnmower are on opposite ends of the map. This map is so complicated that we can't visualize it. Our brains stop at about 3 dimensions, but the maths behind it doesn't care. The maths works perfectly well regardless if it's 3 or 3 million dimensions. And it's all those extra dimensions where the real magic of AI lives. When researchers trained models on billions of sentences and plotted millions of words onto this map, they discovered something that nobody expected. It wasn't just that similar words were clustered together, it was that the directions between the words also carried meaning. Let me explain. If you draw an arrow from man to woman, the arrow points in a specific direction. Now, if you draw an arrow from king to queen, it points in almost exactly the same direction. Same with uncle and aunt, and boy and girl. That direction is consistent and repeatable. And so it encodes the concept of gender. Nobody programmed that. The model just discovered that on its own. And it doesn't stop there. The direction from Paris to France is the same as the direction from Tokyo to Japan and Canberra to Australia. And that direction represents the capital of. So what the model has done is build an internal geometry of human concepts such as gender, nationality, etc., and all encoded as directions in this mathematical map. So that brings us back to this equation. King minus man plus woman equals queen. So here's exactly what's happening. You take the vector for king and you position it in this space. You subtract the vector for man, and what that does is strip away the context of maleness. So what you're left with is a point in space that represents something like a monarch. Now, if you add back the vector for woman, you're reintroducing gender, but this time it's the female component. And the point that you land on the nearest possible word is queen. This was first demonstrated by a team at Google in 2013, and it stunned the research community. And that's because the model was never taught what gender is. It was never taught what royalty is. It somehow learned this abstract structure of these concepts purely by observing the patterns of how humans use language. And that's a great discovery. This vector representation, points as words and meanings as directions, is a foundation layer of every large language model in existence. So when AI generates a response to your question, it's not looking up answers in a database. It's navigating through this geometric space of meaning. The models have constructed a mathematical map of human meaning that's so precise that you can do arithmetic on it. King minus man plus woman equals queen. So now the big question is whether it is understanding that or it's just mathematical logic. And that's a really big discussion in the AI world right now, and I'll let you come to your own conclusion. But whatever it is, it's far more sophisticated than what most people realize. And if you're making decisions about AI for your business or your career or your investments, it's great to understand what's actually happening under the hood. And that's the exciting world of vector mathematics. So if that shifted your understanding even a little, please hit subscribe, and I'll continue to break down AI technology in a way that cuts through the hype and gets to actually what matters. I'll see you in the next one.